Okay, so the new higher precision mount for the CT scanner is now installed in the Faxitron X-ray unit. As shown in the previous video, this came in as two separate sections, then the mounting rods inserted in the sockets, and the set screws were tightened down, which presses the rubber feet up against the top unit of the imaging chamber. In contrast to the previous mount, shown here, this was just a stepper motor attached with some 3M dual lock. It's basically a high-tech Velcro, and that was basically Velcroed down to the bottom of the Faxitron unit. And it was a bit difficult to align with the imaging axis, both in angle and translating position along the imaging array. That has been replaced by a stepper motor which now connects to an ER11 collet to hold things with more precision than the set screw on the older unit. And that stepper motor mount is then connected to an optics kinematic mount, which gives this pitch and yaw control. So by inserting a little adjusting wrench in the bottom set screws there, you can turn these and angle the axis of the spindle up and down or left and right across the imaging array. In addition, that's mounted on a translation stage up top, and that can drive the entire assembly in and out. So with a combination of those, the sample rotation axis can be centered along the imaging array, and it can be aligned perpendicular to the XY axis on the imaging plane. Now, this mount also has a number of other 440 tapped screws, which will accommodate the Thor Labs 4mm rods. The 4 rods on the side are on 60mm apart for a 60mm cage system. Up on top, there's a cutout for the X-ray beam to come down. That also has a 60mm cage mount. And with that, what you can do is you can mount a collimator, and that will slip right in here, and that would restrict the X-ray beam, instead of that fan beam coming down, to just a very narrow pencil beam right down the center of the array. And that hopefully will allow future development of the system, not only for X-ray imaging and CT scans, but also to do materials analysis with a higher resolution by X-ray fluorescence. So the beam would come down, would strike whatever sample you have there. That would excite the electron shells, and they would give off the characteristic X-rays. Now that would have to be detected with an energy-sensitive detector. The Hamamatsu imaging arrays are not energy-sensitive, they're just intensity-sensitive, so I would have to put in a cadmium zinc telluride or a semiconductor detector to detect those scattered X-rays off the sample. But that's not too hard a modification to make, and that would just mount on some of these rods. So to align the system, we put in a sample which is parallel to the imaging axis. In this case, I would be using a mill bit. This is one of those carbide tip mill bits, 0.4mm. And then I would take several X-rays and adjust both the translation of the stage in and out and the tilt of the stage on the left-right axis until it's aligned with the imaging frame. Now if we move over to the computer here, we can see that alignment. I've added some cursors to the imaging screen here. You can see that is that carbide mill bit. The red dashed line in the middle is the center of the array, and these other two cursors are 55 pixels apart. And by adjusting those screws, what you can see is that that center axis of that 0.4mm PCB drill is perfectly aligned. It's not only aligned on center, but it's also aligned in yaw on the imaging array, so it's not tilted up and down. And you can also see with the cursor, the two other cursors here, the top cursor is aligned with the top side of the bit, bottom cursor is aligned with the bottom side of the bit, that both of those are equidistant from the center of the frame. So this is indicating that the new scanner is aligned with very high precision, so this should help with the imaging resolution in future scans.